Formation of the Milky Way. Okay, so as we said, there's a cloud, a giant cloud, collapses due to gravitation, cloud of gas, mostly hydrogen and helium, that comes from the Big Bang. It collapses. The larger stars undergo very quick, very massive supernova explosions, seeding the remaining stars in the gas that remains with first generation metals, if you will, and then as the disk of the galaxy evolves, more stars undergo supernova, and further evolution takes place. And then, of course, you eventually get stars like our sun forming, which has about 2% of its mass as metals. All right, so and of course these stars out here in the halo, way out here, don't undergo the same evolution as the disk. The globular clusters don't have a lot of gas and dust in them. There's not new star formation. They're just very old population 2 stars. All right, so these are just the steps. I'll just go through this. The proto Milky Way is a giant cloud of pure hydrogen and helium. We see the existence of very old population 2 stars with very little heavy metals and elements, suggesting they formed very early. All right, massive population 2 stars explode early on and seed the galaxy. All right, so eventually you have stars like the sun forming, and further into the future, billions of years from now, you're going to have stars, with more percentage of, it'll start to approach 3% and then 4%, when new stars are forming. All right. So one of the things that we have to do, and have done, of course, is do computer simulations of this. So plug in as much physics and actual observational information that we can. You got to make some assumptions, of course, and then you, like in this particular simulation, you have a nice as it shows down here in the last slide E, a nice spiral galaxy forming, right? So the computer simulations are one thing. It does help us in the sense that we think we're on the right track, that the right ideas are certainly in place when our computer simulations can show us the spiral galaxy forming. Then I guess that's called the collapse model. But it does, as it says, it fails to explain 2 important properties of stars. Population 2 stars appear to have formed over a longer time scale than the collapse model allows, and some stars should have virtually no heavy metals. But those are the ones, of course, that I called and are typically called population 3 stars, which are not, we don't find any populations 3 stars. Today, now, the modern idea, and we're going to find this a lot more in the next chapter, the chapter about galaxies, is that we think that there were a lot of galactic mergers. So on a galactic scale, stars, the entire galaxies merged, and that merger process caused the evolution of stars to accelerate much faster than it would have done in just this collapse model would have allowed. Okay, we're going to see this a lot. This idea of galactic mergers, especially happening in the early part of the universe. Although the mergers are still happening even today. Okay, I forgot there was a slide that says this. So there are these things called population 3 stars. These are theoretical. These have not been observed. And here's some reasons why we think that they have never been observed. So we think that these things were really massive, and they didn't last very long, and so we don't find any today. We think that maybe some of the smaller ones do still exist, but they are acting like population 2 stars. That is, they still contain the original hydrogen and helium, but since these things have been contaminated, these population 3 stars have been contaminated by gases that have been encountered these population 3 stars through explosions, right? So you're sent more these more massive stars explode, sending material out, and then the population 3 stars basically become population 2 stars. All right, the future of the Milky Way. So eventually, we're going to find that the gas and dust that is responsible for new star formation will eventually be all locked up in stars, and we think that that'll be literally hundreds of billions of years from now. The Milky Way will no longer form stars, and so eventually, even the smallest red dwarf star will eventually fade, and you're just going to have like these stellar cinders, if you will, like a cinder from of a fire, like the wood. Of course we're not talking about wood here, but if you just think about a fire and you look and you see a cinder, it's still glowing with heat, but there's no more fuel left, and eventually it'll just cool off. All right, so that's the future of our Milky Way galaxy. And let's see. Good. All right, so that's the end of chapter 16, and we will take this up again. We'll take up more of this in chapter 17, which is all about galaxies.